Hello, welcome back to my channel. Today we are going to discuss on VIP question chapter 9, quantization of light. Okay, so for this chapter, okay, the equations that usually we will use is the photon energy equals to work function plus K maximum. Okay, where E, the photon energy, we can use Hc over lambda, or we can use Hf. For work function, okay, we can use Hc over lambda naught, where lambda naught is the threshold wavelength, or we can use Hf naught, where f naught is the threshold frequency. Okay, and K max here is actually kinetic energy. Okay, so the equation for kinetic energy is half mv squared, and we also notice that K maximum, or the kinetic energy, also equals to potential energy, where the equation of the potential energy is equals to EVS. Okay, where Vs is the stopping potential. Okay, so let's start with the questions number 1. The ultraviolet photon with 200 nanometer wavelength are incident on platinum, which has the work functions of 5.6 electron volt. Determine the maximum kinetic energy of the emitted photoelectron. So we want to determine or to find the kinetic energy. Okay, so the equations that we can use here is Hc over lambda, because they give you the wavelength, okay, equals to work function plus K maximum. Okay, where K maximum is the unknown that we want to find. So we substitute in. H is 6.63 exponent negative 34. C is 3 exponent 8, the speed of light, and the wavelength is given 200 nanometer. Okay, so this is the incident wavelength. Okay, equals to work function. So the work function is 5.6 electron volt. We can convert it into joule. 5.6 electron volt. So electron E is 1.6 exponent negative 19 plus K max. Okay, so please bear in mind that if this is in joule, the work function also must convert it into joule. Okay, so later our the unit for K maximum is joule. Okay, so the answer for the K maximum is equals to 9.945 exponent negative 19 joule. Okay, but the answer here are in electron volt. Okay, so we need to convert joule into electron volt. Okay, so remember that for 1 electron volt, okay, if you want to convert it into joule, okay, you need to times 1.6 times exponent negative 19. Okay, similar, if you want to convert from joule to electron volt, okay, we need to divide it 1.6 exponent negative 19. Okay, so now we want to convert from joule to electron volt, meaning that we need to divide it 1.6 exponent negative 19. Okay, so the answer for the K maximum is equal to 0.62 electron volt. So the answer is A. Okay, questions number 2. Okay, what is the frequency of the photon with the wavelength of 550 nanometer? Okay, we can use equation C equals to F lambda to find out the frequency of the photon, where C is the speed of light and frequency is the unknown. Wavelength is 550 nanometer. Okay, therefore the frequency is equal to 5.45 exponent 14, and the unit is hertz. Okay, so the answer is A. Okay, next we go to questions number 3. Okay, what is the energy of the photon, or the photon energy with the wavelength of 550 nanometer? Okay, so the photon energy E is equals to Hc over lambda, or equals to Hf. Okay, so since the questions give us the wavelength, so we will use Hc over lambda, where H is 6.63 exponent negative 34. C is the speed of light. And the wavelength is 550 nanometer. Okay, so the photon energy is equals to 3.616 exponent negative 19 joule. So again, the answer is given in electron volt. Okay, so we need to convert joule into electron volt by divided 1.6 exponent negative 19. Okay, so the photon energy is 2.26 electron volt. Okay, so the answer here is A. Okay, next question number 4. Cadmium has the work functions of 4.22 electron volt. Calculate the maximum speed of the photoelectron if the UV radiation wavelength is 275 nanometer shine on the cadmium. Okay, so 275 nanometer is the incident wavelength. So we want to find the maximum speed. Okay, so the equations we can use is Hc over wavelength equals to work function plus half nv squared. Okay, so we substitute in H is 6.63 exponent negative 19, C is 3 exponent 8, and the wavelength is the incident wavelength on the metal surface. Okay, so this is 275 nanometer. Okay, and the work function is 4.22 electron volt. So we need to convert electron volt into joule. Okay, 1.6 exponent negative 19. Okay, plus half m, where m here is the electron. Okay, electron is 9.11 exponent negative 31 v squared. Okay, so the value for v, okay, after calculating, we will get 3.26 exponent 5 meter per second. So the answer is C. Okay, next question is questions number 5. Cadmium has the functions of 4.22. The photoelectron if the UV radiation is 275 nanometer shine on the cadmium. So they ask us to find the stopping potential. Okay, so we can use the same method just now to determine the value of the stopping potential, where E is equals to work function plus E stopping, where E is the photon energy, Hc over lambda, and the work function is 4.22 electron volt, so let's plus 1.6 exponent negative 19, and we need to determine the value for stopping potential. Okay, so we substitute in the value 6.63 exponent negative 34. C is the speed of light, and the wavelength incident is 275 nanometer. Okay, equals to 4.22 electron volt. So electron volt we need to multiply with 1.6 exponent negative 19. Okay, plus 1.6 exponent negative 19 V stopping. Okay, so we need to find the value for V stopping. Okay, so after that, so the final V stopping is equals to is equals to 0.3 volt. Okay, so the answer is C. Okay, last question is question number 6. Okay, in a photoelectric experiment, the graph shows the frequency against the maximum kinetic energy. Okay, the graph shows that the y-intercept is 4.83 exponent 14 Hertz. Okay, so this value is actually 4.83 exponent 14. Okay, so determine the photon energy and determine whether the photoelectrons emitted if the incident light frequency is 3.5 exponent 14. Okay, so if you compare with the equations, HF equals to HF naught plus K max. Okay, so we need to rearrange back the equations where y is f and the x-axis is in k maximum. Okay, so f will equal to f naught plus k max over h. Okay, if we divided by h. Okay, so we need to rearrange back f will equal to 1 over h k max plus f naught. Okay, meaning that y equals to mx plus c. Y-axis is the frequency, x-axis is k max. Okay, so from the equation, gradient here is actually equals to 1 over h, and the y-intercept here is actually f naught. Okay, so this is the value for f naught. Okay, now we want to determine the photon energy. Okay, where photon energy equation is equals to hf. Okay, so h is 6.63 exponent negative 34. F is given here, so this is the incident. Okay, 3.5 exponent 14. Okay, therefore the photon energy is equals to 2.32 exponent negative 19 joule. Okay, and the question also asks us to determine whether the photon electrons were emitted. Okay, if the light frequency 3.5 exponent 14 Hertz is shine on the metal surface. Okay, so if let's say you want to let the photon electrons to emit from the metal surface, okay, the frequency incident must greater or equal than the threshold frequency. Okay, where the incident f here, okay, the incident f is equals to 3.5 exponent 14, and the threshold frequency, meaning that the minimum frequency required to emit the photoelectron, is equals to, from here, 4.83 exponent 14. Okay, so meaning that there is no photoelectrons emitted from the metal surface. Okay, so the answer is 2.32 exponent negative 19, and the photoelectron will not emit from the metal surface. Okay, so the answer here is C. Okay, so that's all for this video. We'll continue with chapter 10. See you on next video. Bye.